Okay, extreme values. So
What is that?
let's just review.
Seriously, I do not remember this at all.
I have a
extreme values.
function on a closed interval, right?
Sure.
Closed interval, because the dots are solid. There's a specific interval we're working with. Extreme values are min and maxes. So where would I have an absolute maximum? Yeah, so for absolute max, how about a local maximum? Here. So we have a local max, and we also have one here as well, right? Okay, so keep in mind that if you're given a closed interval, it's a good indicator that you're going to be doing absolute max or min. Now, do we have to have a closed interval to have an absolute max or min? No, we don't, because there's a min right here that's absolute, right? So
wait, if it's not closed, isn't it just going to be relative since you can't prove that it's the lowest point, or does it matter?
No, our function could have arrows here,
And it would still
and we would still have an absolute minimum, right? It just would have no absolute maximum. Okay. What's this one? Local. Yep. So
But you couldn't get an absolute maximum on this one if it wasn't open interval?
could not. No, if this continued forever, there would be no absolute maximum, but it doesn't. Okay. So, and they're usually we're pretty sneaky about asking those absolute maximum problems. Okay. We'll look at some free responses the next few days, and it'll be like, when is there the most grass clippings? Right? Like yesterday's problem. And they don't say it's an absolute max problem, but it's implied. Okay, so just kind of keep that in mind. How do we calculate min and max? Okay.
What? Your music is like really loud.
For real?
Like I can hear it from over here pretty well. Just confuses me. Like maybe the headphones just not very good at like keeping the sound in. But that's probably it then. Well, when I use those headphones, I use my ways.
Okay. Let's look at this function. We're going to calculate the extrema. Okay, how do we calculate the extrema? You remember?
Find the derivative.
Yeah, so what's the derivative?
3x squared minus 15x plus 24.
Okay, and set it equal to 0. Kind of make that easier.
Factor 3.
Yeah. Good. Taking a 3 out there.
X minus 4x minus 3.
Factor. So x is 2 or 4. What are those called? They are candidates. They're at this point they're critical values or critical points.
Because the extrema is just like the absolute.
Right.
If you are in Key Club, please report to the gym.
Half the school. Okay, how do I analyze critical values or points for min or max? Yeah. And pick values that are gonna be easy, like I'd pick 0 here.
I always forget how to set up this table. When I try to do it, it looks
Yeah,
so
me too.
goofy.
Well, there you go.
And then you just
You don't
put
have to
negative
do it this
positive
way.
at the bottom. I
If
usually
you know
do
your
it-
critical values are 2 and 4, just derivative each side of those. Derive each side of those and you're good. So what's f prime at 0?
Savory's trying to get her class sickness.
Savory?
She's just that one.
That's next hour. Okay, if I plug 0 in, I get 24, right? Positive. If I plug 2 in, I get a positive. 2 squared is,
Wait,
oh, sorry, 3.
Yeah, I was gonna say, do you plug 2 in?
3 squared is 9, 18, 27 minus
Can you just derive it?
54 is 27. That's negative.
Could you use the factored form of it to find it?
Oh, that's right. That's how we do it. 3 minus 4 is a negative and a positive, right? Why didn't I think of that? And that's a positive. So where's our minimum and our maximum? Local max, because it goes from positive slope to negative slope, right? And then local min, because it goes from negative to positive. Okay. This is called the first derivative test.
And then the second derivative test is for concavity, right?
Second derivative test actually is for min and maxes as well. It just uses concavity. So we would say, we would do f double prime at 4, and it would be positive. So it's concave up, which means there's a minimum, right? So that's the first derivative test. And does this have any absolute mins or maxes?
You can't do that without doing endpoints.
Right. So what is a cubic shape like? Yeah, this is we did this in pre-calc yesterday. Families of functions, right? Memorizing your cubic, that's quadratic. Memorizing your cubic shapes, right?
I never successfully achieved that.
It would look like this. It's an eraser.
Well, why hasn't it? That's infinity and look
I am having a fantastic day, thank you. Okay, so a cubic, no mins or maxes on the absolutes, right? Unless we bounded it in an interval, which we're gonna do next.
So do you like new teacher's jacket?
They're nice, and they're warm. I was sweating. Of course, I have full out of body heat anyways, but yeah, they're nice. So we would do something like, oh, let's do a fun one. Find the max of. Is that code word for hard? Let's do a fun one.
Yeah, if you're always like, function, everything that comes in a function.
And then everybody rolls their eyes when my back is turned, right?
Yeah.
I have no comment.
I have no comment on the matter.
I'm not gonna lie. Thank you.
The majority of us.
I'm not gonna lie,
And
either.
then there's
He's not gonna
David.
convert.
Practically guilty
Thank you,
of being
Canyon,
caught
for being a
guilty.
model citizen.
Ooh, that's it.
Nowadays, that's what they're destined to say.
I don't get it.
The comments of this is just like really mean.
What does that look like?
You guys are mean.
Do you remember what an even over an odd root looks like?
I probably blocked that out.
Okay, the even is a squared,
Yeah, so it makes
so it
everything.
makes everything positive. So this is our Lineberg graph. So as a cusp, right? Ooh, okay.
That one makes sense.
Never mind. All right, so we are finding the maximum. Is that possible? Yes, it is. This one actually looks like this, I believe, because it's a negative. But we're just going to stop. Can we calculate the derivative, please?
We could, but we want to.
X minus 1.
Times 1. Good enough. Okay. And then these are the ones that I always rewrite because it makes it very obvious that it's not differentiable at. X equals 1, right? So we have to test this point for the maximum or minimum, right? Because it's a cusp. Just because it's not differentiable, it's still critical. And we have endpoints, so what are we going to use? We're looking for absolute maximum here, right?
You forgot the negative.
Anybody else like to point out anything that's not relevant?
That's what we look
That's
at.
when Mr. Arthur goes 3/4.
It is relevant because what if you're
3/4
answer
is
something wrong?
Yeah, what if you got the answer?
If you are in knowledge bowl, please report to the gym.
So you're telling me if I forget a negative on a test, I can come back and tell you it's not relevant?
Okay, moving on. I did not say that.
You forgot 0.
Where?
On negative.
You say do the easy
So
one.
it's 0.
Why would I do 0?
Or wouldn't you?
Well, it's not an endpoint and it's not a critical value.
Oh, so that's, you only had to do those?
Yeah, just the ones you've calculated and they've given you. This is called the candidates test.
Is it very clear that those are the things that are.
Okay?
Okay.
So keep in mind the difference between local and absolutes, right? With the local, we did the sign analysis with the derivative. With absolute min or max, we are analyzing in the original function to see who is the tallest, right? So if I plug -1 in, yikes.
That's
Come on, really? 1 minus -2 with 2/3. So that's squared is 4, cube root of 4. Okay, fine. Put 1 in. Hopefully that won't matter. I'm serious. Just don't worry about it until, and if something's bigger than 1, we know we can just not worry about it. Strategic thinking, right? So if I plug 1 in, I get 0. Now, hey, look at that.
Danielle phrased it as well.
See, now I don't have to worry about this one because it's smaller than 1, right? And I didn't have to punch it in my calculator or anything. 2? Yeah, that's 0. So here is our absolute max. Okay? Make sense?
Yeah.
All right, so know the difference. That's the big thing that I see people mix up. There's an example in your book of a trig function and a log function. It's not a good one. I will be done now, just in case. Thanks for listening and making fun of me, jerks.
Hey, you're letting us be in this class.
What?
You're letting us be.
I didn't let you be in this class.
I feel like it's a mutual.
I chose you
because
for this
ask that all the
class.
time.
I could very well
That
have
makes it
said,
all worse.
I don't think Dylan's ready for this class.
So you still chose us to be here.
Yeah, you chose us.
No, it's not a choice. It's not really.
It's a punishment.
If I had not put you in this class, I would be doing you an injustice. I think that's enough.
Any more?
You want there to be more?
No.
Because I can add some spiraling in there. I'm sure I could find a free
Please, no,
response
we're
question. 2010B is now fair game. How about that? Number 5B is an extreme value question. From yesterday's homework?
Yeah.
Now you can do it. See why it wasn't. Okay, yeah, I know there's a lot of singles here, but it's no more than usual. I pick and choose, because those are the ones I want you to practice. All right?